So this is Math 175, Calc 1. And we meet online on Zoom every Monday and Wednesday at 11 o'clock. So as far as I can tell, we're never going to meet on campus. It's required that all the lectures be on Zoom, all the exams be on the internet on Zoom or Blackboard. And in principle, we could have some help sessions in the room that's assigned to us in Gillette Hall, but Gillette Hall now is closed because it's considered unsafe with respect to COVID. And if they ever fix it up, then the building may be open, but we can do, the plan is that the whole course will be done online. Now, there are going to be two types of lectures, so this is really very important. So lectures for the entire course are already posted on the YouTube playlist for Calculus 1. So I'm not going to cover all the material in every lecture when we meet. I'm going to expect that you've watched the lecture in advance. And what I want to do in these class sessions is supplementary material, answer questions that you might have, and go over a lot of homework problems. So this is really very important. If you go to the YouTube, the channel is called something like Nathanson Math Lectures. And on that channel, I have a playlist for each of my classes. And on the playlist for Math 175, Calculus 1, I've already uploaded lectures for the entire semester. We follow the syllabus exactly. So there's a departmental syllabus for the course. You can get it from the math department, but of course, it's also posted on the Blackboard website for our course. This is what it looks like. And you see lesson 1, lesson 2, and so forth, all the way through to lesson 28. Because at Lehman, every class meets exactly 28 times a semester. And for each class, the syllabus has the material to be covered and the homework problems for that lesson. And the schedule of dates when each homework is due is already posted on the Blackboard website for the class. The way you write out your homework problems, and instead of turning in the papers physically, you convert them to a PDF file. So almost all printers these days allow you to scan pages and convert it to a PDF file. And you upload the PDF file to the assignment section of Blackboard, and it's graded there. So the only way I can grade homework, and it's exactly the same thing for exams, the only way I can see and grade an exam is when you upload the PDF file of your work to Blackboard. So learning how to do that right away is really very important. The first homework assignment is due on Monday. So this is like the opportunity to master the system if you haven't done this already. Everything that there is to know about grading and so forth when the exams are is already posted on Blackboard. So hopefully you know all that. Okay. But any questions about the technical aspects of the course? How we meet, how it's graded, homework, exams, and so forth? How much each exam counts? It's all uploaded already. And I assume everyone can hear me okay? No one's objecting. So what I said was that the main content of every lecture, of every lesson, is in the lecture that's posted on Blackboard. And what I want to do in these class sections is enrich or supplement them in some ways. So in particular, for lesson 1, which is a review of pre-calculus, almost everything appears already in the lecture that's on YouTube. But the one topic I'm going to go into a little bit today is on trigonometry. So as part of this pre-calculus review, there is trigonometry, trigonometric functions, which in the textbook is in Appendix C at the very back of the book. So let's start. Angles, degree measure, and what is most important is radian measure. So suppose you have a circle. Here's the center. You take some line, I'll call this the initial ray. Call this the terminal ray. This point at the center is the vertex. So this is the angle. This is the vertex of the angle, the initial ray, the terminal ray. And we denote the angle usually by the Greek letter theta, which looks like that. And when you learn about angles in high school, you have degree measure. So a right angle, which is the only angle that was defined in Euclid, if you use degree measure, it is 90 degrees. That little circle stands for degrees. And an angle theta, which in degrees is between 0, strictly between 0 and 90 degrees, is called an acute angle. And an angle theta, which is strictly between 90 and 180 degrees, is called obtuse. So here we have a right angle. This angle is acute. This angle is obtuse. And that, I assume, everyone is very familiar with. But there's something arbitrary in the measurement of angles by degrees, because someone picked a number. Really, it was the Babylonians, who like to use base 60 in their mathematics. And if you go around the whole circle, it's said to be 360 degrees, but there's nothing natural about the number 360. It's just a nice number. And once you get certainly into calculus, you never use degrees to measure angles. You use what is called radian measure. And this is in some sense a much more natural measure. So here you have an angle theta. Let's say this circle has radius 1. So this is a circle of radius 1. And what is the circumference Well, the circumference of a circle is 2 pi times the radius. So if the radius is 1, the circumference is 2 pi. You go all the way around the circle, the length of that is 2 pi. And the radian measure of an angle is the length of arc of the sector of the circle of radius 1 defined by the angle. So here we have a circle of radius 1. This is the center. Here's the angle. The sector is this part of the circle. And the arc that that sector cuts out is this. And the length of that arc is the radian measure of the angle. So, for example, the radian measure of a right angle is what? Well, you have a right angle in a circle, cuts out exactly a quarter of the circumference. So it's 1/4 of 2 pi, or pi over 2 radians. So another way of saying that is 90 degrees equals pi over 2 radians. What is 360 degrees? Well, 360 degrees is all the way around the circle. So the sector that that angle cuts out is the whole circle, and the radian measure is the circumference, which is simply 2 pi radians. What about an angle of 45 degrees? Well, 45 degrees is 1/8 of a circle. So it's 1/8 of the circumference. That's pi over 4 radians. "30 degrees, well, that's 1/12 of the whole circle, pi over 6 radians. 60 degrees, that's 1/6 of a circle. So in radians, it's 1/6 of 2 pi, or pi over 3 radians. Okay. That is how you measure arcs in radians. You can actually make a nice formula for this, because 360 degrees equals 2 pi radians. So 1 degree is 2 pi over 360, or pi over 80, pi over 180 radians. So if you have a 40-degree angle, that's 40 times pi over 180, which is 2 over 9 pi radians, and so forth. So you can go from degrees to radians by this formula. Okay. Any questions about this? Well, okay. So then we have the trig functions. So I'll just remind you what they are. They're all based on having a right triangle. So here's an angle theta, and this is the right triangle it determines. This is called the hypotenuse of the triangle. This is the side opposite the angle. And this is the side adjacent to the angle. So there are 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. The sine is defined to be opposite over the hypotenuse. If we call the adjacent side x, the opposite side y, the lengths of these sides, and the hypotenuse r, this is y over r. Cosine is adjacent over hypotenuse is x over r. The tangent is opposite over adjacent. The cotangent is adjacent over opposite, x over y. This is the reciprocal of one of the tangent. The secant is hypotenuse over adjacent. That's r over x, which is the reciprocal of the cosine. And the cosecant is the hypotenuse over the opposite sine, which is r over y, which is the reciprocal of the sine. So these are the 6 basic trig functions. And there's some basic identities that relate these. They all derive very simply from the Pythagorean theorem. So the Pythagorean theorem says if this is x, y, and r, x squared plus y squared equals r squared. Let's call this angle theta. If you divide by r squared, you get x over r squared plus y over r squared equals 1. But x over r is cosine theta, y over r is sine theta. So from this, we get the fundamental identity, which is cosine squared theta plus sine squared theta equals 1. If you divide this by the cosine squared, this is for cosine theta not 0, because you can't divide by 0. This is 1 plus sine theta over cosine theta squared equals 1 over cosine theta squared, which is 1 plus the tangent squared equals secant squared. And so on. If you divide it by the sine, you would get 1 plus the cotangent squared equals the cosecant squared. But these two identities follow immediately from this fundamental identity. We also have the addition and subtraction formulas for trig functions, which you will require, which you need to know in calculus. Let me just write down the two basic ones, which are that the sine of the sum or difference of two angles, theta plus phi, this is sine theta cosine phi plus cosine theta sine phi. And the addition formula for the cosine is cosine theta cosine phi minus sine theta sine phi. And there's some other basic formulas that you use a lot, namely that the sine is an odd function. The sine of minus an angle is minus the sine of the angle, but the cosine of minus an angle is plus the cosine of an angle of the angle. So this is what is called an odd function, because when you change the sign of the argument, the sign of the function changes. And this is called an even function. Now, to evaluate this, there are a couple of numbers you need to know, and you really need to know them. So in geometry, there is the following fact about a right triangle where in degrees, this is 30 degrees and 60 degrees. And in radians, which is the right way to measure, this is pi over 6 radians and pi over 3 radians. And if the hypotenuse is r for this triangle, x and y, the side opposite an angle of pi over 6 radians, is half the hypotenuse, and the side adjacent to an angle of pi over 6 radians is square root of 3 over 2 times r. So the cosine of pi over 6 is root 3 over 2. The sine of pi over 6 is a half. The tangent of pi over 6 is 2 over root 3. Sorry. It's 1 over root 3. Or if you don't like roots in the denominator, root 3 over 3. And for pi over 3, you can look at the triangle like this. This is pi over 3. This is pi over 6. This is r over 2, and this is root 3 over 2r. So the cosine of pi over 3 is a half. The sine of pi over 3 is root 3 over 2, and the tangent of pi over 3 radians is root 3. And the other important angle is pi over 4, or 45 degrees. Of course, if this is pi over 4, this is pi over 4. This squared, this equals this, so this squared plus this squared, or 2 this squared, is equal to the hypotenuse. This is r over root 2, and this is r over root 2. So the cosine of pi over 4 is 1 over root 2, or root 2 over 2, however you prefer to write this. Sine of pi over 4 is also 1 over root 2, or root 2 over 2. and the tangent of pi over 4 is 1. So these values of trig functions at these three particular angles, pi over 6, pi over 4, pi over 3, you absolutely and positively have to know. And if you know them, you can solve certain simple trigonometric equations. Of course, I've been drawing pictures of angles really just in the first quadrant. And you can ask, well, suppose I have an angle like this. So let's say this angle is 120 degrees, which is exactly 2 pi over 3 radians. Now, in this case, the x component of this angle is negative. And if we were to look at this triangle, you might say, well, let's see, if this is 1, this is minus a half, and this is plus √3 over 2. So the cosine of 2 pi over 3 is minus a half. The sine of 2 pi over 3 is plus √3 over 2. And the tangent of 2 pi over 3 is equal to minus √3. In general, if you look at the four quadrants, in the first quadrant, the cosine is positive and the sine is positive. In the second quadrant, cosine is negative, sine is positive. In the third quadrant, the cosine is negative and the sine is negative. And in the fourth quadrant, the cosine is positive and the sine is negative. It's because here x and y are positive, here x is positive and y is negative, and so on. But sometimes people like to call the reference angle is the angle that this terminal ray makes with the x-axis. In this case, this would be the reference angle. In this case, this would be the reference angle. And you take that angle in absolute value and you look at the value of the sine or cosine and you give it a positive or negative sign depending on what quadrant it's in. So suppose we want to solve the equation sine theta equals minus √3 over 2. So we would say, first of all, sine theta negative means the angle theta is in either quadrant 3 or 4. Okay. Y is negative. Now, what angle has a sine equal to √3 over 2? It's this angle pi over 3. So if your reference angle was √3 over 2, but it's negative, there are only two possibilities. It could be this angle, or it could be this angle. This is pi plus root 3 over pi plus pi over 3. And this angle is 3 pi over 2 plus pi over 3. This is 4 pi over 3. And this is pi over 6. 5 pi over 3. So the equation sine theta equals minus root 3 over 2 has two solutions. And there they are. Okay. Any questions about any of this? I see on the chat, someone's in Gillette Hall. So first of all, Gillette Hall is supposed to be closed because it's not safe. And we're never going to meet in Gillette Hall. We're only meeting on Zoom. I know that the for some reason it says Gillette Hall room 225 on various official documents, but this is a synchronous Zoom class, and lectures are never held on campus. So for the future, just keep in mind, you don't have to go to campus anymore. You can sit wherever you're safe from COVID and log onto your computer. Okay. Any questions about this trigonometry? Yeah. All right. So again, let me just say what I said at the beginning. All the lectures for this course I have recorded and are already posted on YouTube. For each class, I will mention a little bit about the lecture, but the Zoom sessions are for going over homework problems and answering questions. So there's a homework assignment for Monday, and which you will write out and submit to assignment 1 on Blackboard. And in class on Monday, I will basically go over homework problems. So are there any questions about this? This is no, this is the way it works. It would be better if we were on campus and there is no such thing as COVID, but that's not the state of the world right now. Okay. And then we are done for the morning. You can email me at any time. My email, you can email me either directly or through the email function on Blackboard. And I check my email every day, so I always get back to you within usually the same day or the next morning, but always within 24 hours. We meet Monday and Wednesday of next week. The week after that, CUNY is closed Monday, Tuesday, and Wednesday, so we actually have a week break on what would normally be the third week of the term. Okay. If there's nothing else, then stay safe, everyone, and I'll be back on Monday. Bye all.